so I have it for reference. And we're going to write the original problem, which is skeleton form, because we want to fill in y and x. So y is equal to negative sine of pi over 3 minus x plus 2. Okay? So now we fill in, oh, sorry, I didn't do a skeleton form for x. That's my bad. We fill in x and y. So that's 1 for our y, and our x is negative 13 pi over 6. Sorry, that's a little squeezed in. So our first thing we're going to do for our next step is we need a common denominator for pi over 3 and pi over 6, which is going to be 6, right? Because you can just get 3 times 2 to get 6. So you don't even have to do anything to this one. That's nice. So you got to get an ugly one here, which is 2 over 2, to get this in terms of pi over 6. So this becomes 2 pi over 6 minus negative 13 pi over 6. 2 negatives make a positive. That's nice. Plus 2. All right, so this is 1 is equal to the negative sine of 15 pi over 6 plus 2. All right, so we can go ahead and try to find this. So we're going to need to divide this, right, because this is not something you'd find in the first revolution of the unit circle. And remember, whenever you're checking, you need to use unit circle. I almost blanked on this up at the board once. I was like, wait, how do you get this? So if you've forgotten, don't worry. It's been a while. So this is 15 pi over 6, 2, so we got 12, and we got 3 pi. So that's 3 pi over 6, which simplifies to 1 pi over 2, and you get rid of the evens, the even wholes. And there is no odd number, so we don't add anything to that. So it's just pi over 2. So now we need to go in our unit circle and find that. All right, so it's not negative, so we just kind of go up and stop. This is pi over 2. All right, so we want the sign of that. Ignore the negative for now. We'll apply that later. So the sign of that is the y, and this point, if you remember, is 0, 1. So the sign of that, the y, is 1. So in other words, we're looking at 1 is equal to negative 1 plus 2. Now negative 1 plus 1 is 0, plus 1 is 1. So 1 equals 1. So your graph is right. And there we go. Now, inverses. Isn't that fun? I don't have my straight edge on me, and I don't think I have the paper I did this on me either. So, apologies. Yeah, no, I didn't do this one. Apologies for the lack of preparedness. Sure, I'll use my old sophomore ID. All right, so I'm gonna go ahead and erase this, just so we have some room. I know this is very long. I would have split it up if I realized it, but it's a little too late. All right, so we've already got our graph drawn. The only thing we're gonna do differently, now that this is our cosecant graph for the inverse, is we're gonna make this a dotted line. So if you forget